Hey guys, today we're going to take a look at lesson 3.3, the general addition rule. So the first thing we're going to take a look at is mutually exclusive. Two events cannot occur at the same time. They are mutually exclusive. So if we look at our examples here in those pictures, A and B are mutually exclusive when they never overlap. But A and B are not mutually exclusive when they have that overlap. Okay, so let's check out mutually exclusive events. Decide if the pairs are mutually exclusive. Event A, roll a 3 on a die and roll a 4 on a die. These events are mutually exclusive because they cannot happen at the same time. Go ahead and try the next two pairs. Pause the video and come back for the answers. Okay, hopefully you got a chance to try those. Here are the answers. Our second set, roll a 5 on a die and roll an odd number on a die. Those are not mutually exclusive. They can happen at the same time because 5 is an odd number. And then event E and F, be right-handed and be a nursing major. Those can happen at the same time, so they are not mutually exclusive. So how does that tie into our addition rule? The addition rule is the probability that event A or event B will occur. So that or tells us that we're using the addition rule. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, if your event is mutually exclusive, then the rule can be simplified to just the probability of A and the probability of B. Because when they're mutually exclusive, they cannot occur at the same time, and so the probability of A and B equals 0. So let's see how that would be used in problems. So using the addition rule, you can select a card from a standard deck. Find the probability that the card is a 4 or an ace. So it wants to know, are they mutually exclusive? Yes, the card cannot be both a 4 and an ace at the same time. So we can use the simplified version. Probability of 4 or ace is the probability of 4 plus the probability of ace. So if we find those, probability of getting a 4 is 4 out of 52, plus the probability of an ace is also 4 out of 52. So 8 out of 52, or 4 out of 26, 2 out of 13 is what that would reduce down to for the probability of getting a 4 or an ace. Okay, our second one, you roll a 6-sided die, find the probability of rolling a 2 or an even number. Are these mutually exclusive? No, because 2 is an even number, so those events can occur at the same time. So our probability of 2 or even is the probability of 2 plus the probability of even minus the probability of 2 and even. So the probability of getting a 2 is 1 out of 6 plus our probability of getting even, that'd be 2, 4, and 6. So 3 out of 6 minus how often does 2 and even happen at the same time? Just once, so 1 out of 6. So 3 6 plus 1 6, 4 6 minus 1 6 brings us down to 3 6, or 1/2. Okay, let's try it with our two-way tables. So this two-way table has to do with the classes that you like, and if you're right-handed or left-handed. So let's find our totals. So the total number of people that are right-handed, we add everything up from this row. 5 plus 7 plus 6 plus 8 will give us 26. Then all the people that are left-handed, 2 plus 3 plus 2 plus 1 gives us 8. And then people for math, we add up that column, 7, English 10, science 8, history 9. So when we add these together, we should get the same total. 26 plus 8 gives us 34. 7 plus 10 is 17, plus 8 is 25, plus 9 is 34. So 34 participants. So we're going to use those numbers to put into our addition rule. So find the probability that a random student likes math or likes history. Are these events mutually exclusive? Yes, because you had to pick one. So you can't like math and history at the same time for this survey. So we do math or history is probability of math plus the probability of history. So our math was 7 out of 34, and our history was 9 out of 34. So that gives us 16 out of 34, or 8 out of 17. Then if we look at find the probability that a random student likes English or is right-handed, are they mutually exclusive? No. In the survey, you can be right-handed and like English at the same time. So we have to add in that, so it's probability of English plus the probability of right-handed minus that English and right-handed. So if we look above, when we find our probabilities, English was 10 out of 34. Right-handed was 26 out of 34. And then there were 7 out of 34 that enjoyed both English and were right-handed. So, oops, that should be a subtraction, not an addition there. So they're all over 34, so we look at their numerators. 10 plus 26 is 34. Minus 7 is going to give us 29 out of 34. So for these next two slides, this last part of our lesson, our check for understanding. So I want you to try both of those, make sure you think about if they're mutually exclusive or not, and then come back and check the answers. Okay, go ahead and check your answers here, pause if you need, and then here are your answers for the second page as well. Let me know if you have any questions about our lesson.